Hello everyone. So today we will discussing about binary search algorithm using divide and conquer approach. Okay. So the content are as follows: introduction to binary search algorithm, how the binary search works, and the analysis of time complexity of binary search algorithm. Okay. Now what is binary search algorithm means? So binary search algorithm is a searching algorithm, okay, that finds the location of a specified element in the sorted array. Okay. The array must be sorted for the binary search. So we are finding the location of our element in that array. If location is found, so we will return the index of that element in the array. If it is not there, we can return -1. Okay. So if we compare binary search with linear search, so binary search is more efficient as compared to linear search, because we are taking less time to search the element in the array. Okay. As we know, the time taken by linear search is big O of n, while the time taken by binary search is big O of log n. Okay. So we will see how this we got answer is log n, okay, while discussing the time complexity. So before applying the binary search algorithm, the array must be sorted, that we have already discussed. So the best case time complexity is omega of 1, and the worst case time complexity is big O of log n, and the average case time complexity is theta of log n. That we will discuss how we got omega of 1 and log n factor for this analysis part. Okay. Now moving to the next, let's see how this binary search algorithm works. Okay, we are first writing the algorithm. If you understand the algorithm very carefully, you can easily write the code for that also. Okay, so what the input to a binary search means? So suppose we have n elements in the array. Okay, we have n elements in the array. So all the n elements in the array, that must be what? That must be sorted. So we must have the sorted array elements. Okay. Now we are finding the location of x. So we are taking x as the key. So we are finding the location of our key element in that array. So what this binary search will give us? So what the output of binary search means? So this will return the index of I if x is found. If x is there means it will simply return the index, otherwise it will return the -1. Okay. So let's take this array. We have the array elements such as 2, 4, 6, 8, 10, 12 and 14. Suppose we are finding the location of 8. So our key is 8, that means our x is 8. So we'll see how this algorithm works, and the same can be applied for 4 and 14 also, okay, while finding the indexes. Now binary search algorithm. So this is our algorithm part. Okay. So yeah, so what is the array we have? So you can say the array that we have is like this. So this is our array. So we have 1, 2, 3, 4, 5, 6. Okay. So we have 2. Okay. Just a minute. Yeah. We have 2, then 4, then 6, 8, 10, 12 and 14. Okay, we have this array elements. Suppose we have the value of n is 7 here. Total we have 7 elements. So the index is 0, 1, 2, 3, 4, 5 and 6. Okay. So we are having two variables I and j. The I will point to the lower bound, that is at index 0, and j will point to the upper bound, that is at index 6. So this is the I and j we are using. Okay. Now we are finding the mid. So mid will be simply I plus j by 2. You simply do I plus j by 2, that is a mid. So what is the value of I? It is 0, that's j is 6, divided by 2, answer is 3. So that means the third index is our mid. Okay. Suppose if you say, sir, what will happen if our array has even number, suppose 0 to 8, 0 to 7, total 8 elements are there. So in that case, how we will find the mid means, since we are using the integer int mid, so it will take the lower bound. Okay. So you can take the int as a mid. Here mid is as an integer. So if you get the answer is suppose 3.5, so only we can take 3 as the our mid. Okay. So just remove this as of now. Okay, just remove this. Now, so next continue our discussion. Yeah. So this is the mid. So we'll find mid as I plus j by 2. Now what will happen? Now this is our binary search algorithm. Okay, we have written BS for binary search. We are passing the ARR, means base address of array. Suppose this is our array ARR. We are passing the value of I, J and X, where I and J are the indexes. I is pointing to 0 location, or we can say lower bound index 0, and J is pointing to the upper bound, that is at index 6, and X is our key that we are looking for in this array. Okay, now suppose I and J are equal. What this statement means? I and J are equal means the array is having only single element. Yes or no? Suppose array is having only single element, that means I is also pointing to this index and J is also pointing to this index. So what does it mean? So if they are equal means, so that means only one element there in our array. So we'll simply compare the index of this ARR of I with the X. Okay, now suppose let's take X as 2. Now 2 is compared with the 2. Yes, we got the match. We found this element here. So we will simply return I. You can write I or you can write J also, because both are pointing to index 0. Okay, that doesn't matter. You are writing I, you can write J also here. So this is the if part. Now suppose let's take X as 3. Now what will happen? Suppose we are finding X as 3 means, now in this array we have one single element, 2 is not equal to 3, so we will move to the else code. So that means we are not getting this index, this element does not exist in our array, so we will simply return -1. So this is the simple case of binary search. So here you can say this is taking order of 1 time, because in a single comparison, okay, we are simply comparing the ARR with X. Okay, so it will take order of 1 time. Okay, so it is a constant operation, just comparing the these two values. Now what will happen? Suppose let's take the value of X as 14. Now what will happen? Now since this we are this the value of I and J are not equal, so we'll move to the else part. If they are equal means we are entering inside if, outer if I and J are not equal means it has more than one element, so we'll move to the else part. Okay, so in else part what will happen? We'll compare with simply with the this we are comparing A of mid with our X. So what is ARR of mid? Sorry, it is ARR. Okay, ARR of mid. So ARR of mid is our that is ARR of, what is the mid value? That is 3. And what is X is, and the X value is 14. Okay, so simply check, it is 8. Whether 8 is equal to 14? No, that means our element lies on the right half of the array. Okay, just remember, if mid is equal to our desired element, that is called the best case of binary search. Okay, if mid is our X, that's in a single comparison we got the answer. If mid is not our array elements, so that means the element lies either on the right half or on the left half. So if this one what we say, what we are comparing A of mid with X. Okay, so here 8 double equal to 14, that is false. So that means either our element lies on the right half or on the left half. Okay, that we will see. Okay, now if you let's move to the next. Let's take the else part first. Okay, here I have written the recursion, so that will be more easy for you to understand. So again let's draw the array here. Okay, let's draw the array here. So this is our array. Okay, we have 2, we have suppose 4, 6, 8, 10, 12 and 14. Okay, so we have this array 3, 4, 5, 6. Now we know I is at 0, J is at 6. So we have found the mid value. The mid we got as I plus J by 2. That is 0 plus 6 by 2. The answer is 3. So this is our mid. Okay, this is our mid. Now here you can see, so we are comparing of first is if we are comparing if AR of mid with the X. So what is AR of mid? The AR of mid is your 8. Let's take suppose X 8 first. Okay, Now ARR of mid equal to x. So we what is the AR of mid? 8. 8 is double equal to 8. Yes, we got the element in the first comparison only. So this is called the best case of the binary search. Okay, so we are simply returning the mid. So what is the mid index? 3. So we can say 8 lies at index 3 in our array. Okay, so 8 lies at index 3 in our array. So this is called the best case example of binary search if mid is our element. Now suppose let's take x as 14. Now what will happen? We'll simply follow this approach and we'll compare mid with the x. So what is the mid value? AR of mid is 8. Just compare here. Go to this else if, because this will not work if x is 14. So AR of it, that means 8 is equal to 14, that is condition is false. So we'll go to else if ARR of mid method. What will happen? So what we are getting means we are receiving 8. 8 is greater than 14? No, it is false. Again go to else part, that means our element lies on the right half. So for that means the array that we got, okay, that we need to recursively search. It is 10, 12 and 14 and the indexes are 4, 5 and 6. So now our new I will be this, the new I will be a 4 and j will be a 6. Yes, so answer is what? So it is again we will find the mid value. What is the mid value? 4 plus 6 by 2, that is 10 by 2. Answer is 5. That is, this is our mid. Okay, this is our mid value. So that means again we will compare mid with our element. If mid is found, that we can simply return the index of mid, else we go to either left half or right half. So here you can see we are simply designing a recursive tree. So if we take our mid was 8, so either we go to left or we go to right. If you go to left, our mid is 4. Okay, if you go to left, our mid is 4. If go to right, our mid is 12. So if you go to again left, our this again we got 2 and 6 here, and we have got here 10 and this 10 and 14. So you can see we are simply forming a tree structure. Okay, so the height of what is this tree? Log n. So we can say the time complexity of binary search is also log n, because in order to go from root to desired element, we are traversing the whole tree, whole path of the tree. So it will take log n. Okay, so this is the binary search. Now if you go to previous slide, so let's take the analysis part. Find the mid, it will, since it is a constant operation order of 1 time. Comparing is also constant operation order of 1 time. Again we are comparing, so it is also 1 time. Here you can see either we go to this one, this binary search, or this binary search. Either we go to left half or right half. Yes or no? This either if or else. So let's take, so it will take, since we are dividing by 2, so we are the time taken will be t of n by 2, where we are using tn as the time complexity to denote the for this binary search. So either we go to left or we go to right. So we are taking single tn by 2. We are not writing 2 times tn by 2. Okay, remember that, because it is if else. Either we go to if or we go to else. So it will take let's take it as tn by 2. Why we are writing tn by 2 means, since we are again dividing the array into 2 half, no? So again it is recursively calling. So it is dividing, and okay, until find the desired element. So if you sum up this this one, that is we are writing like this, that tn by 2 it is equal to plus order of 1 plus order of 1 plus order of 1. Since we are having 3 constant, so I can replace this 3 order of 1 with c. So that is our analysis part. Okay, so that what I have written here. Here you can see if array has single element, so that means just we got in one comparison, so we got the element. Now if array has more than one element, so we need to recursively call. So it will take tn by 2 plus c. What is c? C is the constant, where c constant is order of 1 plus order of 1 plus order of 1. So instead of writing this we are using the c as the constant factor. Okay, so let's have the recursion relation. So how to solve this binary search? So here you can see, so initially we have Tn by 2 plus c. Okay, this is what we got. Again it is divided into 2, so that means this we can write let's use yeah, okay. So here you can see this is T n by 2 to power 1. Yes, we can write it is a 2 power 1. Again it is dividing by 2, so that means this is divided by 2. What will happen? 2 power 4. This 2 power 4 can be written as 2 power square. Again divided by 2, this n power 8, and the n power n divided by 8, so n divided by 8 can be written as 2 power 3. So here you can see we are getting a pattern 2 power 1, 2 power 2, 2 power 3, like this. So if you repeat this for till k steps, k times, we can reach to that element. So we are taking at log n as the this height, or we can say factor. So to reach to k this times, we are taking the log n time. So we can say, so again this c will be repeated k times, so that means c will be repeated log n times. So now if you write like this, T n by 2 power k, this same will be repeated up to T n by k plus c into k. If you replace k with log n, so we will get order of 1, and here you get the log n. So since order of 1 is a constant, just neglect this constant, so we will get the answer as order of log n. So just remember, so the worst case time complexity of binary search is order of log n. Okay, so this is the analysis part. Now let's move to best case. So best case will be when we got when we are finding the mid, and mid is our desired element. Okay, so this is called the best case analysis part. So if we are looking for the element, and that element is found in the first comparison itself, so that we say the success attempt. Okay, so in one comparison we can find the index of that element with the help of the mid value. So answer is the best case is omega of 1. So please note here ki in best case we are not calling binary search algorithm recursively. Okay, we are just finding the mid. If mid is found, so we can say we are having the best case. Okay, now what is the average case means? Now, so average case will take all possible comparison from 1 to log n, where that is 1 plus 2 plus 3. So in one comparison, or two comparison, or three comparison, how many comparison we need to do in order to find the x. So total will be this 1 plus 2 plus 3 up to log n. So here you can see it is nothing but sum of n natural number. So what is the formula for finding sum of n natural number? We know it is n into n plus 1 by 2. Okay, so here in place of n we have log n, so we can write as log n plus whole divided by 2. So it is the total comparison, and the average will be divide this total by log n, since we have log n this k times, that is log n. So here you can see just this log n will be cancelled, and this all constant will be removed. So we will get answer as theta of log n. Okay, so just remember, so the average case time complexity of binary search is theta of log n. Okay, thank you so much.